Today we are going to just do some more example problems, especially with some of the stuff that we're seeing on our homeworks. So I just picked out some random examples that we can do instead of actually going through a homework assignment. Okay, g of x equals 1/2 times x minus 2 to the third. It says graph each function on a graphing calculator. We're going to do that by going to Desmos. When I go to Desmos, you should sign up or create a login. Mine's already created, so I can just log in with Google. There's my email address. Just get right in there, and I'm good to go. All right. I'm then going to put that on this half of the screen so I can look at my work on the other half of the screen. It can get kind of messy, but it's worth it. So I start by doing 1 divided by 2 forms 1/2. If I push the over key, it makes it so I'm not in the denominator anymore. Parentheses x minus 2. And then if I push shift 6, it creates a caret, third power. That's my first graph. Now, because this is to the third power, I know my parent function would have just been x and then shift 6 to the third power. Okay, let's zoom in on this graph to see what happens. If I push that little down arrow, it gets rid of my dialog box, and I'm staring just at my graph. Clearly, my original graph was moved over 2 units. So this would be a horizontal translation right 2 units. If I also look at this, this does not appear to be as wide as this one is. And the reason for that is this 1/2 out in front creates a vertical compression. So the fact that it's outside the parentheses is going to make it a vertical compression. You'll remember that from section 1, we looked at compressions and stretches. So then we also have to do the domain and range. The domain for this one, there's nothing that stops it from going down left forever. There's nothing that stops it from going right forever. So the domain is going to be all real numbers. Our range is going to also be all real numbers. It's going to go on forever and ever. Okay. If we click the X's here, it clears those functions out. We can move on to the next one. Negative square root. To do square root, we type SQRT. Turns it into square root for us. You could also just click this button down here. Just as easy to me to do it either way. So then I can do 4x. And then my other option, or the parent function, is square root of x. Let's minimize this, look at the graph. Okay, whenever we look at the graph, we can see that the parent function, which is in black, I can tell it's in black because it's got the black thing right beside it. So that one's the black one. And it goes up, whereas the purple one goes down. Our purple one is a reflection over the x-axis. This 4 inside of here, whenever I look at this, you see how it's not as steep as this one? That's because this 4 creates a horizontal compression. So it's going to be a horizontal compression. It's pretty terrible writing. Now, if I look at my domain is going to be all the x's that are covered in the graph. if I look at this, I can never go into the negatives. So my domain is x greater than or equal to 0. My range for this function is y less than or equal to 0. Reason it's y less than or equal to 0 is because this starts at 0 and always goes down. So that's our range. Okay, number 3. Get rid of those two. Let's start plotting some points. Parenthesis, -2, comma 9, -1, comma 3. You see, I forgot my parentheses. If I don't put those in, it's never going to work. 0, comma 1, 1, comma 3, and 2, comma 9. Okay, let's zoom out and look at our graph. I can see that it has the U shape, which tells me that the parent function is going to be a quadratic function, as that forms the U shape. Describe the transformation from the parent function. The only way I can do that is if I scroll down and add my parent function, x to the second. Let's look at this again. I can see that my bottom point has moved up 1 unit. So it's a vertical shift up 1. And then if I'm looking at these points, they're not as wide as my parent function. And the fact that they're not as wide as my parent function shows me that this is going to be a horizontal compression. So that's my transformation. Vertical shift up 1 and horizontal compression. Okay, sketch a graph for each situation and identify the related parent function. Distance traveled in t hours at 55 miles per hour. If I travel 1 hour at 55 miles an hour, I've gone 55 miles. If I travel 2 hours at 55 miles an hour, 2 times 55 is 110. 3 hours at 55 miles an hour is 165. If I look at this, it looks like it's going up, in general, a straight line. So that my parent function is going to just be y equals x, or a linear function. So this is linear, and the domain would be x greater than or equal to 0. The range is y greater than or equal to 0. Because I can't go negative time, and I can't go negative miles per hour. Even if I'm going in reverse, it's still going a certain miles per hour. For surface area of a cube with the side length c. In order to find surface area, our formula for a cube would be 6s squared. Each side is side squared. There's 6 sides in a cube, so it's 6s squared. So if I start with a side length of 1, then 1 squared is 1 times 6 is 6. So be in there. If I go to 2, 2 squared is 4. 6 times 4 is 24. If I go to 3, 3 squared is 9. 9 times 6 is 54. If I go to 4, 4 squared is 16. 6 times 16 is 96. If I'm looking at this same shape, it looks like it's going up like this. This looks like half of a parabola to me. So I would say that my original function, or my parent function, is a quadratic, or x squared. The domain, I can't have a negative side length, so it's going to be x greater than or equal to 0. My range, I can't have a negative surface area, so it's going to be y greater than or equal to 0. Okay, that's it for these examples.